Friends, let us start with finding inverse Laplace transform of the given signals. Now, in order to find inverse Laplace transform, always prefer partial fraction expansion method. Do not forget the formulas. As we have seen the same cases for Z transform, that is inverse Z transform, we have find it by long division method as well as by partial fraction method. Now here the question is asked, x of s is 1 by s plus 1 into s plus 2, and we have to find its inverse Laplace transform, that is nothing but x of t for three different cases. Case 1 is when the region of convergence is greater than minus 1 pole point, less than minus 2 pole point, and in between that. That means we can say that this should be a right sided signal corresponding to this will be left sided, and this is going to be a both sided signal. So let us start. We'll apply partial fraction expansion first, so that I can write xs is equals to a by s plus 1 plus b upon s plus 2, that we can simply write is equal to 1 by s plus 1 into s plus 2. So if we apply partial fraction expansion without wasting too much time on this one, I'm writing the values directly. The values are a is going to be minus 1, sorry, that is going to be plus 1, and b is minus 1. Now we'll just put those values. We'll get xs is equals to 1 by s plus 1 minus 1 by s plus 2. Now we got a simplified one. Now to find its inverse Laplace transform, we'll use this equation. We have seen this formula also. E raised to minus at into u of t is Laplace will be 1 by s plus a. Now by that we'll try to find this. Now to find this, we have to assume three cases. First case is what? ROC should be greater than 1. Now if you see, this system has 2 pole points. The first pole point is minus 1 and the other one is minus 2. Now from minus 1 and minus 2, if we compare these two terms, definitely minus 1 is greater than minus 2. So corresponding to region of convergence greater than minus 1, we can say that signal is right sided, because property of ROC says that if two pole points are right sided, or if we are having 2 pole points, we can take maximum of it. And by that, for the first case, I'm writing if ROC is greater than minus 1, its inverse will be x of t. Here pole point is 1, so this is e raised to minus t into u of t minus e raised to minus 2t into u of t, because the maximum is minus 1. Now in second case, they are given if ROC is less than minus 2. Now if ROC less than minus 2, if you compare again these 2 pole points, in these 2 pole points the minimum value is minus 2, and if the minimum value is minus 2 and if ROC is less than, that means definitely both these signals are left sided. So we'll write x of t is equals to e raised to minus t into u of minus t, because it is left sided, minus e raised to minus 2t into u of minus t. This is the second possibility. And in third possibility, they have given ROC is greater than minus 1 and it is less than minus 2. Now if you see here, ROC is greater than minus 1, that means corresponding to pole minus 1 or 1 the region of convergence is greater, that means the signal is right sided, and corresponding to 2, it is less than, that means it is going to be left sided. That means for this case, this system is right sided and this is going to be left sided. So we'll write now xt is equals to e raised to minus t, u of t is right sided, whereas e raised to minus 2t into u of t is left sided. So by this you can find inverse Laplace transform. The important condition is determining the ROC terms. So greater than right sided, less than left sided, and in between it is going to be a both sided signal. Now let us see a different type of example, and the question is, let an LTI system function is h of s is s minus 1 by s plus 1 into s minus 2. The question is asked, determine the different possible region of convergence and their corresponding impulse responses, that is h of t, and also comment on stability. Now in first case, we'll try to determine all different possible ROCs and then we'll come across stability concept. Now to form or to determine different possible ROCs, first we'll try to find its inverse Laplace transform by partial fraction expansion. So we'll write s minus 1 upon s plus 1 into s minus 2 is a by s plus 1 plus b upon s minus 2. So we'll get this term denominator as it is. This is s minus 2 plus b into s plus 1 upon s plus 1 into s minus 2. So this two side denominator will get cancelled. Now to find a, we'll try to make b as 0. That can be possible if s is minus 1. So put s as minus 1 in both the side. We'll get this term minus 1 is equals to a into minus 1 minus 2 plus b into 0. So this is minus 2 and this is minus 3. We'll get a as 2 by 3. Next, to find b, a should be 0. Now a is 0. When I equate it 0, s minus 2 is equals to 0, s becomes 2. So if I consider s2, we'll get this side, that is 2 minus 1 is equals to a into 0 plus b into 2 plus 1. So this is 1 is equals to b into 3. We get b as 1 by 3. So this is the coefficients a and b. Now we'll put those in h of s as 2 upon 3 by s plus 1 plus 1 by 3 by s minus 2. Now the different possible ROCs are going to be what? First pole point will be minus 1 and second one is going to be 2. Now the possibilities are what? If it is right sided, it should be a maximum pole point. If it is left sided, it should be drawn with reference to minimum pole point, and it should be both sided also. So first possibility we'll write. You can see the signal is going to be right sided if we take maximum of these two. So minus 1 and 2, if I compare, definitely 2 is maximum. So first possibility we can write, if ROC is greater than plus 2, that means definitely greater than minus 1, hence this signal is going to be right sided. And as we can write, h of t is equal to 2 by 3 as it is. This is plus, so e raised to minus t u of t. This is plus 1 by 3 into, now this is minus, so definitely it should be plus over here, e raised to 2t into u of t. This is when the first possibility. Now in second case, second ROC you can write, it may be possible that the signal is left sided. It will be possible when ROC is less than minus 1. Take minimum value from these two. So minus 1 and 2, the minimum is minus 1. So it should be less than minus 1. Signal is going to be left sided. We'll write 2 by 3 e raised to minus t u of minus t plus 1 by 3 e raised to plus 2t into u of minus t. This is the second possibility. And in third possibility, the signal is going to be both sided. So we'll write the possible ROC combination. Now both sided means what? It should be greater than a pole point and less than another pole point. So if you see, we are having minimum minus 1 and maximum 2, so we can take the possibility ROC should be greater than minus 1 and it should be less than 2. So in between that we can get the region of convergence. So I am writing third possibility is ROC must be greater than minus 1 and less than plus 2. So this is right sided and this is going to be left sided. We'll write h of t corresponding to minus 1 is right sided, so 2 by 3 e raised to minus t into u of t, whereas corresponding to plus 2, the system is going to be left sided, so 1 by 3, this is minus, so exponential should be plus e raised to 2t into u of t. So these are the three possible region of convergence and their impulse responses. Now let us come and comment on stability. Now the system is said to be stable for which terms? So if you see, first case, ROC greater than 2. Greater than 2 up to what? So if it is greater than 2, it should extend up to plus infinity. And if it extend up to plus infinity, definitely system is not going to be converged. Hence it is unstable. Second possibility, when ROC is less than minus 1. less than minus 1 is up to minus infinity. That means in this case also system's response is infinite, therefore system is going to be unstable. Now we'll come across the third possibility. The possibility is what? ROC greater than minus 1. Greater than minus 1, if you draw it, it should be greater than minus 1, okay, and it should be less than 2. This is the whole point as 2, less than 2. That means your region of convergence in between minus 1 to 2. That means it never approaches to infinity and we'll get a finite impulse response. That means you can say that a LTI system is said to be stable if it includes j omega axis. Remember, this is an important term. A system is said to be stable if it includes j omega axis. For this condition, it includes j omega axis. Hence, if ROC is greater than minus 1 and less than 2, then only the system is stable. Or you can write here, system is stable for ROC greater than minus 1 less than plus 2 as it includes j omega axis. So by this you can determine or you can comment on stability. So such kinds of examples you can expect in the university examination. Thank you.